All right, let's just do this in advance. Let's try to prove the one of the most important rules in calculus, the product rule. So here we go. If we let h of x, because fgh, why not? Because f of x over times g of x, and we try to find a derivative. So we're really trying to find a derivative of this thing, but we're just really finding this. Okay. So if we have d over dx, or okay, fine, let's don't do that. Let's just do f dash x. Sorry, h dash x equals to a limit of. Okay, I probably shouldn't use h, but anyway, delta x then. Delta x goes to 0, and if we have h of x plus delta x minus h of x over delta x, that's equals to the derivative from the first principle. There should be no surprise here. But also we can expand this, right? So we can write limit of delta x goes to 0 of, going to be a big chunk here. So f of x plus delta x multiplied by g of x plus delta x, and then minus f of x times g of x, and then the whole thing is divided by 0. Sorry, approaching 0. Yeah, and because since we're doing calculus, then you probably algebra is good enough, and because we've done quadratic formula, we always get things out of nowhere, and same situation in here. We're just going to get something out of nowhere, plus delta x minus f of x times g of x. And from experience and my cheat sheets in front of me, we are going to get this just out of thin air, because why not? Plus delta x plus, so minus this and plus this times g of x minus delta x, and because these two things supposed to cancel out, we still get delta x at the bottom. And now some grouping. So if we group everything by g of x delta x, highlighter, highlighter, highlighter. So if we group this, well, this with this, and the other grouping is this. So if we group these two together, we'll get equals, wrong pen, we'll get g of x minus delta x of this big chunk of fx plus delta x minus f of x plus, close brackets, plus f of x multiplied by g of x plus delta x minus g of x. Just probably take some time to think about it, because it's getting, I know it's getting things out of nowhere, but that's how to prove stuff sometimes. I mean, it's weird. Oops, too big. So because we've got a plus sign here, and there's two multiplication going on, so we've got a plus. That means we can split this out. So we can split that as a big brackets, that as a big brackets. So if we split this, we have g of x. Sorry, we have limit of g of x minus delta x times f of x plus delta x minus f of x over delta x plus, what is it? G of f of x times g of x plus delta x minus g of x. And you see where this is going? Delta x? Well, the limit is a big limit sign in the front, so I don't have to write everything again. Let's see. Well, we don't have to feel guilty. We can just chuck 0 in there. That is just equals to g of x. That becomes g of x. This big chunk becomes f dash of x. This is just, well, f of x. This big chunk becomes g dash of x, because we got a limit at the front, right? So h dash of x, or d over dx of f of x times g of x is equals to, g of x times f dash of x plus f of x times g dash of x. QED. So satisfying.